right, I think we're live again. Okay, we are live. Let me make this more visible for everybody. All right, so stream goals. That's it. We're just gonna work on clouds. I got a little bit of cloud rendering already kind of working. So we've got fog volumes. Again, this is just like extremely basic Beer's law. I need to do some transparency work because, like, you can see the afterburner does not really work well with the fog transparency, nor do the particles. Actually, I can probably fix the particles. Anyway, yeah, this is kind of where we're at. So far, so good, honestly. A few things I want to fix really quick. The UI, like the targeting arrow, it's not exactly functioning the way I would like. So, yeah, that'll be the first thing to be fixed. Let's see. Position, target delta, mouse delta dot y. Maybe it should just be like screen size, honestly. Window manager. I should be here. Window manager. Actually, I don't have any changes that I committed from. No, we're good. Primary window dot height. No, it's window. Gosh darn it. Primary window width. Hey, what's up, dude? Let's see. Okay, that might get the uh-oh. Oh shoot, yeah. My bad. Okay, let's see if this fixes the. Did I just fix the? I'm just stupid. Okay, there we go. That should work. Got it. Now let's see how this functions. Yeah, that feels much better. Does it work when I rescale? It does. Well, it's the aspect ratio we need to take into account. So times window manager, primary window, aspect. There we go. That should give us the mouse movement that I was hoping for. Okay, that seems to work. Okay, and then if I rescale, it's about the same. Okay, perfect. Yeah, although maybe it should be just a little bit less intense. 0.85. I don't really want this to too dramatically affect anything. Okay, that's good enough, I'd say. Yeah, there we go. Actually, time.delta time. Maybe you don't need this time.delta time. Because I feel like all that's going to do is make it frame rate dependent. I don't think this needs to be. Yeah, no, we do need that. Okay, we're not going to break anything else. We're just going to let that be. And then, yeah, let's actually work on the clouds a little bit. Okay. Okay, so far, in terms of cloud rendering, I'm trying to think what the best way to approach this is, okay? So here's our cloud volume. Oh my gosh, wow, that's bright. Okay, so here's our cloud volume so far. Okay? It's pretty basic. It's just using basic Beer's law. Nothing too special, but you know, I'd like to have a sky of clouds. Now, one thing I was initially trying to do is I was taking this cube and I was just scaling it. And that tech, like I was making basically just one giant, very, very thin cube in the sky. That was just going to be like a layer of clouds. And that works really well until you look at, like, it works well if you're looking straight up at the cube, because the way this cloud rendering thing works is ray marching. Basically, you cast a ray from the camera, you find where it hits the cube and where it leaves the cube, and then you, based on the distance the ray travels through the cube, that affects how much transparency that pixel gets, basically. If you're looking up at a thin cloud, that works fine. But if you're looking like almost parallel to it, the distance that the ray steps through the cube gets much bigger, and the only way you can really fix that is you just scale the whole thing up uniformly. But if you do that, then you have to take a lot more steps per pixel, which quickly eats up performance. So I'm starting to wonder if that's the best way to do things. I still might experiment with it. Like, maybe there's a way I can just clamp the amount of steps per ray. I don't know. I might be able to work with it, but another option that I was thinking about was I could just have sort of a fog material, like a cloud material, and then just have a few cloud meshes. They wouldn't actually be meshes. I could use, like, again, this is all ray marching, so I could do this all in a fragment shader, and then I could use like metaballs maybe, and then just like a cloud material being applied to a metaball. I'm curious how performant that would be. Either way, I need to figure this out. So maybe the first goal would be just to get a cloud material working, which shouldn't be insanely hard. So the next step would be to implement noise. And there's a couple ways we could do this. We could do this through some form of... Actually, let me compile this for the browser and quickly make sure that this works. There's a couple ways we could do the noise. We could do like a 3D texture, but I'm trying to think maybe there's a way we could generate some 3D noise in the fragment shader, because I'm trying to keep the build, like the amount of assets used, fairly small. So if we can generate things in the fragment shader, that just works in our favor. Okay. Let's see. There's also some bugs with the window resizing. That works. If I scale this up, does that do anything? Kind of, not really. If I remove that, okay, that's not good. Scale this down. Okay, so scaling seems to work. Not really. Oh, that's another bug to fix. Great. There we go. Okay, I'll fix that later. But okay, browser build's looking good. Clouds material seems to work the same. Okay, so the next thing will be like some sort of 3D noise function, which I'm wondering, let's see, 3D noise functions. Let's see, Perlin noise. Is there like 3D Perlin noise? 3D Perlin. Just 3D noise functions. We don't necessarily have to use Perlin. Yeah. 3D noise. Not 3D Perlin noise. Noise 3. Let's see. Yeah. Okay, maybe there's something in here on how he did the 3D noise texture. Or function, rather. Yeah, he made a cube, permute. Gosh darn it, dude. I don't want to have to implement that. That looks hideous. And that doesn't actually look like the result I want. Okay, maybe there's... We could use a texture. We do already have a noise texture. The problem is the noise texture isn't 3D. How do we do this? 3D noise in a fragment shader. That would be a good question. 3D Perlin noise. I don't want to have to, like, devote a whole bunch of time to just making 3D Perlin noise. GLSL noise algorithms. There we go. Noise. Okay, that takes in a vec3. There we go. Okay, that takes in the vec3. We'll just take this noise function here. We'll make it easy for ourselves. Clouds, and then just, we should have some sort of noise function. Okay, so now the way we're gonna do this is instead of, okay, so we have our min and our max. What was it? Yeah, here it is. Okay, so we have our start point and our end point. So what we need to do is we'll get a array. Let's see. What is it? Full path array equals box space exit position minus box space enter position. Okay, and then vec3 step distance equals, well, step array. Trying to think about this. Yeah, we need to make a constant for that. Define. This probably should be something we can modify in settings later on. But for now, we'll just say steps. And we'll give every cloud, I don't know, 15 steps. And then step array equals full length array divided by, oh my gosh, divided by step. I think it was just step, was it? Yeah, steps. There we go. Okay, and then while step array is not equal to box space exit position. And then at the end we'll just say step array plus equals step. Or not step array. I'm trying to think. Yeah. It should just be, well, actually, we'll just make vec3 step distance. Yeah, step distance. Vec3 step array will just be step distance off the bat, and then we'll say step array plus equals step distance. And then instead of, oh, we need to move this up here. Entry T, yeah. Okay. I should probably put this up here if we want to exit out quick. Okay. And then the distance, this is easy. So we'll just have our distance float here. This should change absolutely nothing. If we do this correctly, let's see. Distance plus equals length step distance. This should just work the exact same. Of course it doesn't because I did something wrong. There's definitely some sort of cannot implicitly cast. Oh, yeah. Yeah, I forgot about that. We need to cast that. Okay, yeah, there's still another error somewhere. Non-L value. Assignment to non-L value. What? Incompatible options for link. What am I doing wrong here? How? Enter position, step array, plus equals step distance. Dr. Michael Teschner, right? Yep. Not doctor, though. Mr. Gosh, yeah. Let's see. That's weird. I don't even... Assignment to non-L value. We're not... Everything here should just be working. While that step array... Okay. What could this even be caused by? You know what? We'll just plus equals step. Full path area divided by float steps. Like, what are we doing wrong here? Okay. Let me just see some examples of what that is, because I know what this error is. You're trying to assign a value that cannot be modified. Yeah, okay, I'm aware of that. What am I doing here? There's some really stupid error that has to be happening here. Exit position minus enter position. That's totally valid. That's totally valid. We're not assigning. Is there something wrong with this macro? Maybe. I've never done. That wouldn't make sense. That really would not make sense. But yeah, that's not the issue. Okay. Assignment to non-L value. Maybe it's this. Let's see. That's an odd thing to put in the chat. Yeah, MD explains. Got it. What? Let's see. Vec4 ray direction. And we should just return nothing. I don't know why we're doing that. Vec4 0.0. I don't think that should be causing any issues, but at the same time, like, why is this? I guess we'll just move it back to where it was. That wouldn't make sense. Like, that this wouldn't fix anything. Assignment to non-L value. Distance. Oh my, whatever. It's been a long day. Okay. Uh-oh. Shit. That crashed. Really bad. Okay. Thought I broke my computer there for a second. Let's see. Okay. The issue is we're running into an infinite loop. Okay. The safer way to do this would be int num steps equals 0. And then while num steps is less than int steps, and then num steps plus plus. I don't think there is plus plus in we could just wrap this in a for loop. Ah, see, that works. Okay, see, that works the exact same. And now we can sample noise along the way. So, yeah. Okay. Length, step distance, and then there should be some sort of noise thing. So then we'll say we have our noise function. Where was that? Noise, and then we'll just put step array. That should give us some distortion. That does give some distortion, it seems like. Maybe. Maybe not. Hold on. It doesn't seem to be doing the most. Maybe. Maybe like step array, and then we should multiply it. Because this is also a pretty. We're doing this within like the space of the cube. There we go. Okay, that's something. It's kind of weird, but it's something. We should convert this into world space. Yeah. Because we convert this into what? Traverse volume. Where, let's see, traverse volume, extract position, get world direction. Ray origin. Because we are doing that. Okay, so we should just get the world position of this. Let's see. Vec 3 world ray. World step ray equals vec 4 step ray 1.0 times transform, and then we'll just swizzle that dot xyz, and then boom. Hopefully that works, or does something. Okay, so something's happening. I can see the noise is like really, really grainy. So maybe 0.1 is a better play. Still has that same issue. We should be getting the world space transform of this ray. Yeah, also you can't fly into the volume. I'll fix that later as well. Okay. Times. What am I doing wrong here? Let me think. This world calculation didn't really make a difference. So maybe it's like plus equals noise. Maybe we don't even need any sort of any of that. That's pretty potent. We can divide it by maybe 100. And then this will be a much more subtle accumulation. That looks better. I could be wrong. No, I can see the cube part of that. It's not really fixing our issue. That's disappointing. Yeah. Once again. Okay. So how do we resolve this issue? Okay, so it should be distance as well. Let's see. Let's see. GLSL clouds. Real-time volumetric clouds. Yeah. What was the yeah, ray marching? What? Yep. Okay. Return origin. Oh, that's a sphere. Let's see. So he's just doing standard ray marching, and then he's applying some sort of weird shader to. Oh, that looks like my bug a little bit, honestly. I don't know if this is the technique I'm using. I think this is something different. Yeah, he's not exactly using my methods. Let's see, shader toy. That looks pretty good. How does he do the render? Where's the stepping? If inside. Oh, he's got a lot in here. Yeah, I don't need it that deep. What? Is this a noise texture that he's using? Ray marching clouds. There's less than cloud density. Okay, so there's a cap as well. That's good. Let's see. Cloud density, density function. And he passes in the current position. Okay. And then he gets and then he's just returning the sum, which is just color times whatever this alpha piece is. Okay. So it is just it's the density function. It's probably just the fact that I'm using, frankly, noise. Huh. Okay. We could just snag hit this. Would this work? Because this is just a density function in GLSL. This should just work. Let's see. Hash, weight, octaves. Yeah, this should be standalone. Let's see, would this work? Full credit. Let's see. Full credit to this guy, Daniel Scherzer. Yeah, this guy. Check his profile out because he seems to have a pretty cool cloud implementation, and I don't want to ever use someone's code without giving some credit to him. Let's see. So we'll just switch out the noise thing that we have here with this. I don't know why he's doing it this way. You could just do this. I will take the liberty to change these into macros. Yeah, density func. And then we can just replace wherever we use that noise function. Plus equals density func. We don't need the length. It will just be the density function. And of course it doesn't compile. What's wrong? Macro steps is undefined. I have steps still defined, right? Okay. We'll get rid of that. We'll just I don't really like having 150 steps, but we'll see if this even works for now. We're also gonna have to fix all those implicit cast issues because okay. Undefined variable time. Yeah, we don't have time. Is he having some sort of float time equals I global time? Ah, frick. Let's see. Time. No. No thanks. We're not gonna worry about time for now. Yep, okay. And now it's just implicit casting. Okay, that's fine. Cannot cast from int to float. Let's see. Octaves. Weight, noise, P. Where is he casting this? That's probably part of it. And then where was the steps being used? Yeah, that's the issue. This is gonna be really unperformant the minute this works. I probably shouldn't. Let's see, casting to int to float. Access, no, it's definitely this. I've gotten a little too good at finding implicit casts and shaders. Ooh, that's new. That is something. Oh, wow. Holy criminy. Ain't that something? Still a little busted in a couple ways. Like, yeah, obviously can't fly into it. I don't know. Something seems a little off. Oh, I know what the issue is. Oh, I know what the issue is. I know exactly what the issue is. I'm so stupid. So when the ray hits the cube, if it hits a corner, like, think about it this way. If we're facing the cube head on, right now we have it set up to where the ray will always take a certain number of steps through the cube at all times. But not all rays actually travel the same distance through the cube. There should be a fixed step size. So, the fixed step size... What? Gosh darn it. Okay. the fixed step size should just be a unit vector that we multiply. So we'll just say step distance equals normalize full half ray times 0.1f. Okay, that's our step distance. Wait a minute. No, that should work. And then this is going to hopefully not break everything. Oh no, that seems to have broken everything. Okay, so let's think about this. We're normalizing whatever this is, so it's just a unit direction. We're multiplying it by a very small number. Maybe that's the issue. Maybe it's not small enough. Maybe it's just missing the whole cube. Because we're doing this within the cube space, so that would actually make a lot of sense. If yeah, there we go. Oh. Yeah, see, that fixes the issue. Ooh, really, really expensive, but it works, I think. Oh, this is also not in world space, so we should translate this into world space. So we'll say vec3 world step ray equals step ray times u transform xyz, and then we'll take that. We don't need to do that. And then that broke everything. That's okay. Hopefully it's an error. Oh, that's a hideous error right there. Oh, whoops. Back. We should also do what? Matrix then vec4 use step ray 1.0. There we go. That should fix our issue. Let's see. Can we see anything? Is there an error somewhere? There's no errors, so anything wrong now is just purely implementation issues. Okay. It's gone now. Maybe it's... Would that even make a difference? I'm just trying to think about this. Okay, here's an idea. Because from what I'm seeing here, the cloud is what? It's not being like... I'm just trying to think mentally, like, what is going wrong here? Because something's very wrong about this. It's like we're looking through some sort of weird, like, portal or something. So maybe one thing we could do is we could say, based on how... Oh. Okay. We need to take into account how far the ray is traveling. Because right now, things that are close to the center and things that are on the sides aren't being treated any different. So, let's see. This is also still taking the same number of steps, which isn't not really what we want to do. While num steps is less than steps. And while what? We can't just check for like a greater than. We can check if it's within the cube. Yeah, we can. Int ray within AABB. Const vec3 b min const 3b max vec3 array. Well, we could just say point. We could just say within, and then const vec3 point. And then what do we do? Are you learning by doing, or are you just showing us? Learning by doing. Definitely learning by doing. I don't know if I'm the best person to learn from yet. I hope to be. But yeah. Let's see. Yeah, so then what is it? If oh, what's the algorithm? If the x position is okay. If b min this is the easy way to do this. For int I equals 0, I is less than 3, I plus plus. You can do this in GLSL, and it makes working with vectors a lot easier. You can say if b min I is less than or equal to point I, and sometimes the mic falls. Oh man, I wish I had a better setup right now, but the dorm room setup is not very good. Okay. If the less than point is greater than that, or b max I is less than point I, will return false, or rather will return 0, and then otherwise we'll return 1. Okay, that should just check if we're within the bounding box. And then what we can do is we can say, and it within AABB, what was the term? Was it cube min cube max, and then step ray? That's what it was. Wait a minute, step ray should just be full times step distance, right? Well, no, it should be position. What was it? Box enter position plus, what was it? Box enter position. Oh, let's see. What was the formula for array? It was P plus DT. So that's our direction. This shouldn't be step distance. Step distance vector. No, I don't want to change how that's named. Okay, we'll just say plus step distance. That still feels wrong, but okay. We'll for now we'll just place it right there. Yeah, that's our step rate. Starts off there, and then we'll just plus equal step distance. Yeah, that should be correct. That's gonna break everything, I guarantee you. But let's see. Yeah, implicit cast from int to bool. Wait a minute. There aren't bools in. There's bools in GLSL that. Okay, I'm used to that for some. There's no way. I could have sworn. Kudos. By the way, it's cool to see real time other day. Sorry. No, dude. Feel free to interrupt. That's why I live stream. It's fun to talk about things that I'm building. Let's see. Unexpected what? Return false, return true. Somewhere I messed up a parentheses in here. That doesn't make a lot of sense. Does it? Maybe it's down here. Ah. Yeah, there we go. Okay. So now, holy criminy, that broke something. But that fixed our yeah, that fixed one of our issues though. Okay. For now, we're actually gonna just remove that code because I think that's actually messing things up a tiny bit. Yeah, that is messing things up. We'll add that back once it works. But well, it looked like it was working, and then I looked above it, and it suddenly wasn't. Let me think. So the normal way we just did this was we said what? Plus equals length step. What was it? We should just do this once too. We shouldn't. Step distance. Sorry. Step vector. So this is not the step distance. Let's be clear. Then we should have a float step distance equals length of our step vector. And then we could, the way we initially did things was we just said plus equals step distance, right? Well, let's just make sure that this works, and then we can modify from here. Okay, so that does something. It looks like it kind of works. I also seriously think I need to lower the amount of steps I'm taking, because I'm hearing some frame stutters, and it's freaking me out a little bit. Let's see. Okay, so the number of steps is directly making things sound kind of funny. Interesting. I wonder, it should plus equal that, right? Let's see. Plus equals step distance. So the longer we travel through the... Oh, I'm stupid. Yeah, we do need to have and within ABB. And then we just need to fix that. Let's see. Cube min cube max array step array rather. And this is all within the same space, so it should work. Yeah. Okay. So that does something. Not what I'm hoping for, honestly. Yeah, that's not good. There's something here that's like causing some sort of recursive error. Let's see. If min is greater than our current point, or the max is less than our current point, return false. This should be working. I think this should be working. But whenever I see that swirly thing, I think something's not right, obviously. We shouldn't step that many times unless we need to. Maybe it's that our step vector is too small. Maybe we should be taking less steps. That seems to have made it a little cleaner. Okay, that is making it a little cleaner. So there's something going on with like... So when we get closer to it, it seems to fix it. Interesting. Okay, that looks a little better. I can see what's going on here. This is within AABB, is still messing stuff up. I'm not totally sure why. And then this should break everything. Yeah, that's correct. But that is what we need. I'm just curious why we're having some sort of like weird bug. Step ray. If it's within the box, then that should just work. What is it? What causes the screen swirl in OpenGL GLSL? I've run into this issue before. The screen swirl just is a distortion technique. No. The screen swirl ring issue in while loops, because I know it's relating to the while loops. Last time I fixed this, there was something with like an infinite function. Yeah, warping artifact within while loops, generally caused by undetectable loop driver optimizations. Within a while loop has a variable init exit condition. Driver cannot easily unroll it. Okay, compiler might create incorrect fix rate. The driver will stop the shader. Okay, so what I'm seeing is we should use a for loop. Okay, for, and then we'll just say int n equals 0, n is less than num steps, n plus plus, and then we also can just throw this in here, and while n is less than that, and that, steps plus plus, n plus plus rather. This should fix it, I think. Nope. So it is being caused because things are just taking too many steps. Because the farther away we go, the more this issue happens. Why is that the case? Step vector is just full path ray. Why are we normalizing it? It should be some fraction of the regular box distance. Okay, so this should take what? A certain... Yeah, but that's the same issue we had from earlier. I don't know why that's happening. Gosh darn it, I've seen this issue before. Yeah, that's our step vector, and then our step array just starts there, and then we increment it throughout, and then we just plus equals step distance. Maybe it's the number of steps. And within AABB step array. This plus equals step array. Gosh darn it. It really does not like for loops, isn't it? Maybe it's because we just have too many steps. Maybe this works if I keep it really low. Nope, not even that. Okay, maybe something is going on. Because it's whenever I add this. Something's breaking out early. That's what it is. These pixels are breaking out early. Isn't this... what? Simple AABB intersection. GLSL. What? I think I implemented this right. Maybe it's like a floating point issue. Things that are like on the border. Yeah. Check over all three axes. That's exactly what I'm doing. If any of these aren't the case, you know, that... I don't... It should just break out and return false. This point should not be causing any problems. Maybe we... No. This won't fix it. I guarantee you this won't fix it. But it's worth trying, I guess, at this point. Because the problem is it works. Like, this is performing proper ray marching. It's just... When I get far enough away, it stops working. Why is it that when I get far enough away, this thing refuses to work? I mean, I guess we could just do the fixed step method. I'm just trying to think. Gosh darn it. Cube min, cube max. Maybe we're passing in the wrong parameters. Nope, min, max. If the minimum is greater than that, if any of those are the case, we return false, otherwise we return true. That maybe there's something going on with like a compiler level optimization because I'm passing in that const or something. I don't freaking know. Gosh darn it. Yeah, as I fly further and further away, these artifacts become more and more visible. Why? Is it a floating point issue? What could it be? Okay. Maybe we do our initial technique of taking our full path ray and in fact dividing it by steps. This way, no matter what happens, we will take the same amount of steps in the cloud. But that also means we will into float, yeah. But that also means if we just factor the fact that, you know, we've traveled a much shorter distance in the cloud, and that should not change anything. We should get the same effect. Okay, that looks about correct. We're not getting into those weird artifacts. And then we can get rid of our within this thing method, though that might be useful in the future, if it works in the future. And then we can just do density func step ray. And then because we've taken a shorter, you know, step, our density function will be accounted. Oh, that works. I'm proud of that. It only took how many tries? Let's see. Yeah, buddy. That works. We have the first semblance of clouds. Now they're very low to the ground, and that's because we need to tweak this a little bit. Step 1, clouds move. No, they don't have to move. Let's see. Octaves, FBM, weight. Something's being accounted for. Yeah, P.Y. We don't want that. The Y should not be factored into this. It should just be uniform. There we go. No, here's what it should be. It should be the distance from P to the center. So we'll pass in a point, and then depending on how far it is from the center of const vec3 center, and then it'll be minus distance. Reminds me F29 retaliator. I'm curious, what is that? F29 retaliator. Oh, I definitely, you know what, I didn't, oh, yep. Yeah, I never played this, but I see where you're getting that from. Yeah. Yeah, that's a cool comparison to make, honestly. Yeah, so the farther away it is from the center. Now, this will be linear, so we could do like a fall off of some kind. And then what? We'll have our, let's see, box entry. We need our, actually, this is just, it's always in box space. So it should just be 0, actually. Uh-oh, no, something's wrong. No, is something wrong? The distance can be a little too strong if I had to guess. So maybe it could be like distance divided by 10. So that's a little softer of a fall off because of the distance. Yeah. Yeah, okay. That seems to be a little better. Actually, here's an idea. Float distance fall off equals 1.0 minus distance to the center. And then clamp this. Whole thing gets multiplied by distance fall off. And then that should allow us to pretty easily modify how things fall off. Now it's kind of, I think, doing maybe the opposite of what we wanted. Is it maybe doing the opposite? Yeah, it looks like it's... Is it, actually? What? There's also should be just a density factor here that we're missing. Octaves, there's some constants. Absorption. We'll up the absorption a ton. There we go. A little too intense. But it works. For the most part, I would say. We do need that fall off to work a little better, though. Yeah, that looks pretty cool, actually. It seems like it's a little... The distance from the point to the center. It should be density function. I want to see if this is doing what I think it's doing. Make sure I'm multiplying the right things. Yeah, there we go. Okay, so I guess it really is just... The distances might be just much smaller than I was expecting. Yeah, I can kind of see it already starting to take effect. I just guess it needs to be even smaller. This should really make the effect intense. But it's not. Okay, what the heck? Maybe it's all far from the center? Well, That wouldn't make sense. Because our cube min and cube max shouldn't be... Yeah, 0, 0 would be the center within those. So the issue is somewhere with our distance fall off. What? If we just were to make it something really small, would this make any difference? You know? Yeah, that definitely looked pretty clearly doing something. But then if we subtract it with distance, nothing happens. Right? Yeah. Suddenly nothing happens. That's so weird. What is this value? Is it... Well, let's do the opposite now. Let's just experiment. Oh, that did something. What the heck? Whoa. It's kind of cool, actually. It kind of fits the style. It's actually really neat. We can get that effect really easily if I just forget about this. We'll fix that fall off thing a little later. And then if I just reduce the steps a lot, we should just get that effect out of the box. Yeah, see? We're kind of getting that ray marching visual bug. Hey, what's up? Yeah, that definitely kind of maybe works a little bit. We'll do like 30. I don't think we need 50. Yeah, 30 looks about right. And then we should make it fall off based on the distance from the center. But maybe we should do it here. Float distance fall off equals 1.0 minus distance step ray vec3 2.0f. And then we'll just multiply it by that. So things that are farther away from the center have less of an influence. There we go. That worked. For whatever reason, that worked. But the previous method didn't. That's okay, I guess. And then we'll make the fall off just a little bit more intense. We should probably clamp this. We don't want negative values, do we? Yeah, we definitely don't want negative values. So we'll clamp this whole thing within 0. We'll take the max 3.0. Okay. And this will be a little bit more potent. And then we can just really crank up the fog density. Yeah. And then fog density will be absorption, rather, 100. Yeah, there we go. Some semblance of clouds. And I will now make it where we can fly into them. And I know how to do that. So first thing, what's basically happening is it, what is it? The reason it's not rendering things is if we never enter in the key, how do I put it? If we call this function and we're inside the cube, or at least the ray starting point is within the cube, it basically counts as a miss. So what we should do first is okay, after this test, we should do one more check. If entry t is equal to that, and what? Oh, we need that AABB bounding box function, don't we? Okay. Bool is within AABB. const vec3 point vec3 const vec3 b min const vec3 b max, and then for int I 0, I is less than 3, I plus plus. This I really don't know what's going wrong with this shader code. To the best of my knowledge, this should just be working. If b min I, so if this component is greater than point I, would that be, yeah, or b max is less than point, b max I is less than point I, return false. Okay, and then otherwise return true. Okay, and then the next move would be if not is within AABB. Q. We need the camera's position. Box space ray origin. Ray origin will just be for the camera position. Got it. Okay, box space ray origin, cube min, cube max. Then we'll do that. Otherwise, actually, hold on. Better would be if we are within the cube, then we can say, and entry t is equal to this. Then we can say entry t is equal to what? Oh, what was it? What are we using entry t for anyway? Entry t times box space entry position equals that. Is there inline? Let's see. If, okay, we'll say bool is within box equals this. So we only compute it once. And we just say is within box and that. What? Entry t is being used for all of that. Else if entry t is equal to 1e30 f return vec4 is equal to 0. Okay. Otherwise, we don't even need the entry t. We could just define this off the bat. Then we could just say box space entry position is just equal to box space ray origin. And then otherwise, let's see, if it's within box, else if. And then by default, we will just do that. Okay. There. So let's just walk through this. We'll do this. If this value is way too big, but we are within the box, we'll just set it to whatever our ray origin is. Otherwise, nothing. We remove all that, and then our exit t is that, box space, exit position. Okay. That should now allow us to fly through the cloud. Okay, so the original logic works, and then let's fly in. Okay. Didn't work. Why didn't it work? So maybe it's just this is within box method isn't working. Okay, well, we can check this really easy. Is within box, return vec4 1.0. And this way, we'll know this works because our screen's just going to go red when we fly inside. Otherwise, okay, so it just doesn't work. It just does not work. That's fine. So the issue is within this method. For whatever reason. AABB intersection. What? I don't understand. Why would this not be... I don't need a ray intersection. I literally just need to know if a point Simple point within box GLSL. Yeah. AABB. Yeah. Yeah. Point box min. If point is less than box min, that's what I'm doing here. I don't understand. Why is this not working? Is within box. What the heck? This should also be const. That's so weird. Yeah, flying thing, once we leave, it's visible again. Draw 2 rectangular boxes and fly between them. Draw 2 rectangular boxes. What do you mean? Like, just for fun or to test? Because this is a box. This isn't a sphere. This is a bounding box. I just need to know that we're inside of it. Because the camera position, yeah, okay. If is within box, we'll just do that. That shouldn't really fix anything, if my logic's right on this. If we are within box, we just need to fix this method. Okay, we just need to fix this. If we can fix this, everything should be easier from there. Okay, let's see. Is within a box. GLSL AABB. Why would this not be working? Oh, there's an all method? Ooh. That, I've never seen this before. This looks like something out of JavaScript, I'll be honest. What? All greater than, and we'll just add a comment here. This is AABB point checking. All greater than or equal, and all less than or equal point. And what is this all method? Returns true if all elements of X represent. Oh, so this is how we can perform operations with vectors. That's really useful to know in the future, honestly. Cube min, cube max, box base rate origin. That's really interesting. Now, will this work? Still doesn't work. Interesting. Maybe this is causing some issues somehow. That wouldn't make sense. Control flow wise, that wouldn't make any sense. Yeah. It just doesn't. It just doesn't want to do this. Box space, direction, entry T. What a strange issue. I really don't want to use AI. I try to avoid that. But this might be something worth using? I don't know. I don't want to use AI. But at the same time, this is frustrating. This is very frustrating. Gosh darn it. Why would this not? We're so close to being able to just fly through clouds. Like, that's something I really want to be able to do. I mean, this cloud thing looks really good, actually. I'm really happy with... Uh-oh. Yeah, I'm really happy with how that looks. And I think it... Like, this should work with just regular ray marching, so I should be able to use any shape that you can represent as a signed distance field. But see, once we're inside the box, it stops working. I'll compile this for the browser. so that I can run the web build of it just while I'm thinking. Yeah, finish successfully. Okay. Oh gosh, yeah, I have to fix the mouse picking. Interesting. Oh, we didn't change any of the C++ code, so yeah, that's something that I don't like about WebAssembly. When you recompile, you know, it doesn't recopy your assets, and yeah, it is what it is. It's really not that big a deal. It's really not a big deal. Okay, let's see. The web build. Oh, it works. Works in the browser too, thank goodness. And the transparency is still a little broken, but maybe I can like write to the Z buffer or something somehow. I'll look into that later. But the clouds, they don't look too bad actually. They're kind of gray. But that looks like a circular cloud. That's pretty cool. I can make it denser too. Actually, let me make it denser. Let's have some fun with this, you know? Let's see. Density, func, step ray, distance fall off. What? Game feel is nice and PvP in the future would be sick. Yeah, it's gonna happen. After clouds comes multiplayer. And then after multiplayer comes weapons. That's the roadmap. It's gonna be awesome. Let's see. Times distance fall off. Let's see. Times 10. This should make the clouds a little bit more like dense. Yeah. Not exactly what I was trying to do, but you can see we're running out of steps and you can like tell. So maybe that's not the play. Maybe the play is not 10 times bigger. Maybe the play is like 2. You know? 2 times more dense. Yeah, that's still, you can kind of see the effects. Yeah, maybe you just leave it as leave it as is. If it ain't broke, don't fix it. Yeah, we'll stick with the 30 steps. So I guess the next question would be, gosh darn it. This is so frustrating. How is this not, screw it. Screw it, I'm gonna ask Claude. Cause this isn't something I can just like use a debugger to figure out. It's just this code that should be working flat out ain't working. So let's see. Why is the all AABB intersection method always false? Let's see. What could this be? I don't even think. Let's see. Ray origin is in world space. It's not in world space. It says that this is in world space. This is not in world space. I put it in the space for the box. World space. But you're checking it against box space bounds for transformations applied. What are you talking about? Box space, entry T. This should actually work correctly. It went back. Claude went back. Let me just show you the goofiness of this. This should actually, so it tells me, you know, oh, here's your problem. You're absolutely right. But this should actually work correctly. Camera's still outside the volume, yeah. Transformation, no. Floating point precision. To debug, add this. How would, if box space ray origin? Yeah, that's actually, I see that's a way we could debug. Okay. Let's see. Because it should just be, if I'm within 0.1 distance, everything goes green. Yeah, that doesn't even work. Holy cow. Oh, I know what the issue is. The code's working. I'm sorry. I'm an idiot. And my AABB method also works. The issue is we're inside a mesh, and we have culling enabled. Let's see. Yeah. Okay. Graphs backend. Cull. Let's see. Set backface culling false. Yeah, we don't want any backface culling true. Because now we can fly inside the mesh and it shouldn't all just disappear. Because this is actually material. It is not a post-processing effect. Yep, it all goes red on the inside. Okay, perfect. So that means, technically, this should work. Now this should work. Okay. Can we fly into the clouds now? We can! And it works. Now, there is kind of a weird thing that you can see with the cube boundaries for some reason. Oh, gosh darn it. Transparency is doing some weird stuff. Oh, you gotta be kidding me. Well, wait a minute. So this method, once I fly in the cloud, everything looks, you know, looks fine, looks dandy. Then I leave the cloud. Okay, so this needs to become a post-processing effect. But here's the thing, if we make this a post-processing effect, then every cloud has to be passed to the GPU, and I want to avoid that. So we're not going to let this be a post-processing effect. We're going to fix this bug. And the way we might have to do it might be atrocious. This might be the most disgusting thing ever. Yeah, this is not ideal. But at the same time, oh, I can't believe this is happening. So what we could do is we could disable backface culling only when our camera's within the box. And then when we're outside the box. Oh, that's disgusting. Okay, I don't care. We have performance to spare right now. Let's see. Back 3. Back 3. Box space camera position equals what? GLM inverse, and then scene manager, active camera, get view matrix, and then times. Wait a minute. No, it's wherever our current transform is. So it'll be transform, and then times. Let's see, what was it? Scene manager, active camera. Get view matrix, right? Wouldn't that be it? No. Wait. It's the position. Sorry. Dot position. Okay. And then we can do our same bounding check. So we'll have a private method. Honestly, this should just go in the math utils thing. Static bool AABB point. Point within AABB. Const GLM rec 3 min. Oh well, we should probably do the point first. Const GLM rec 3 point. Const GLM min. Const GLM rec 3 max. And we're just doing this in the header file. This is such a short function. I think we can also do this in GLSL. Sorry, in GLM. If point I is less than, can we do that? Is it a B? Float 3, right? Float 3? Why does... Okay, that's kind of weird. Fvec3, right? Can we do that? Okay, you know what? Screw it. We'll do it the normal way. Bool x equals what? Point dot x is less than min, or point dot x is greater than max dot x. And then we'll just, for the y and z as well. is less than min max z or is greater than max, return not x and not y and not z. Okay. Or it would be x or y or z would be a better way. X or y or z. If none of these are true, we're within the box, right? And it's still building. Okay, that works. And then we'll say math utils point within AABB. Point within static bool. What? Why is... Oh, we haven't included it. All right. Okay, include slash utils math utils. Let's see. If math utils point within AABB, box space camera position, GLM vec3 negative 1.0, f GLM vec3 1.0 f. If this is the case, then we'll disable backface culling, right? Why is this giving me an issue? Point within AABB. That's correct. That's correct. Oh, whoops. And then otherwise, we'll just draw normal, right? I feel like that should work. Inverse. Finished with exit code 1. Okay. Transform is not derived. Oh. Inverse. Transform. Wait a minute. The transform that we have has its own get matrix, right? Transform that get matrix. Got it. Okay. And then that should allow this to work. What? Can't multi. Ah, yeah. Like 3, 4. 1.0. Please tell me we can do that. And then GLM vec3. What a nasty one-liner right there. Hopefully GLM can handle that. Oh, perfect. Hold on. No, that's not what we need. Run desktop. Okay. So that is rendering correctly. Now, if we fly in, do we then enable culling? No, we do not. Okay. That's fine. That just means our backface culling logic. No? That's not good. Test. Maybe this will do something right. Okay, so that's the problem. It's just not working. So if our point.x is less than our min, or it's greater than our max, why is this always true? Oh, what am I doing? If this is not the case, and this is not the case, and this is not the case. Yeah. There we go. We just had it backwards. I was not thinking straight. Okay, let's see. Instantly kind of works, and then there's that horrible flicker for half a second, which probably means this is what we need. Because it's probably happening right when the camera's on the border. It's not sure what to do. So we need this to be inclusive. And that should work. Let's see. Fly into the cloud. Yikes. Still does that flicker. Gosh, that's ugly as heck. Still doing that flicker. Is it because we're also doing it in the shader? That could be it, actually. Hold on. That could be it. Greater than, equal, less than, equal. Do we have... No. Well, so what the heck is going on here? Oh, here's an idea. We'll just make it slightly bigger than it needs to be. And then this way, we shouldn't have that ugly flicker. There should be enough time in between. There. A little too obvious. Maybe 0.1 is a little better. Just right before we enter the cloud, we disable this backface culling. Okay. See, a little. That was a little too close. You could see that. Or maybe that was the problem. Maybe we needed a little more narrow. Yeah, that's the issue. Okay. Interesting. That ugly snap, man. Can we push this even closer? Because this solution, as horrible as it is, does work in a very basic sense. We shouldn't have to recalculate how we're doing this, though. That's the... Maybe there's a way we can just do it like this always, and then have the shader just work consistently. Maybe that's what we should be doing. Because having this backface culling disabled causes some issues. So maybe it's just an alpha blending problem. Okay. Like why is that visible? There should be no shading. Oh, maybe that's the issue. Maybe the issue is that somewhere the color is still being factored in here. Like, that shouldn't be having any effect. There should be literally just this. Let's see. Let's search blend mode. Blend mode. Not SDL. I don't have an SDL renderer in this. SRC blend. Blend func 1 minus source. GL1 minus source alpha. Dist color constant alpha. Let's try that. I have no idea if this is going to do anything in our favor, but there's something with the blend. Oh, shoot. Don't change that. Blend. Source alpha. Okay. That's frustrating. Okay. But it does seem to, in some sense of the word, work. I just don't like the fact that you can see the freaking corners of the square. That's what's really bothering me right now. Like, why is that the case? Is it because it's taking more steps or something? Like, it's got to be something like that. It's definitely something along those lines, which means what? Maybe it's the distance fall off. Maybe this will fix all of our problems. Oh, shoot. No need for a distance fall off there. Anymore, at least. Okay. So, does this fix our issue? Can't see the back of the cube. That's good. No, you can. It's just way right there. We can fly through the clouds. That's awesome. It's just that ugly back of the cube. I'm curious, though. Could we fix this, hypothetically, with a unit sphere? That could be interesting. Let's see. Blender. Let's get a unit sphere. Yeah. Let's do unit isosphere, actually. Just so it's all evenly distributed. Shade smooth. Edit mode. No, it's all good on its own. Export GLTLF. ISO. .gltf. Yep. All right. Oh, we also should export all the normal data. Mesh tangents. Export. There we go. Now if we reload this, this should not be create cube. It will be loader, load mesh from GLTF resources slash meshes slash ISO GLTF. And that should change this from using a sphere to a cube. But doesn't seem to really fix our issue. The normals still seem to be those creases, man. What's going on? There's something going on with how the normals are being calculated or something. Something's weird here. Like why are these visible on the inside? Disable backface culling. Okay. So the cube is gonna still be our go-to. We just need to fix this issue somehow. If it even can be fixed. Probably can't be fixed. Definitely can be fixed. Okay. How are we gonna do this? It's something with the alpha blending. Okay, we're using the cube. No, this is the isosphere still. We need to rebuild. Yeah, there we go. Okay. So, clouds. The back of the cube is visible. Why? This whole thing should be essentially invisible. I don't even know why this would be happening. Wow. Ask cursor, little bro. I try to avoid that. If I can, I avoid asking AI to solve my problems. But yeah, see, we're inside this thing and it works fine. It's once we leave, suddenly everything starts behaving funky. Like the backface culling kicks in. So, disable backface culling. OpenGL backface culling transparency issues. Backface culling transparency issues. Because we're not. Yeah, it causes incorrect rendering order. Yeah, render order. Disable depth right. GL depth mask before rendering transparent objects, then re-enable. Okay. Graphics backend set. Looks like you're trying to make a shadow of a cube and smoke. No, it's the issue. I'm trying to make clouds using ray marching, and that's not I would say, insanely difficult. It's just finicky right now. That seems to have solved the problem. Okay. And we fly in. It works. Clouds. We have clouds. We have a very general semblance of clouds. We'll have to modify the density function a little bit. But steps. We'll up the steps a little bit. 50 steps should be more than enough. Yeah, that is more than enough. Yeah, we have clouds. Okay. How much of a performance tank does this give? If I was to just add a couple other cloud layers. Also, maybe the cloud layer should be an entity list of things. They have to be rendered last, that's for sure. So maybe in the environment. Environment, cloud volume, cloud volumes. Yeah, actually, no, we already have that implemented. We can have multiple. Thank goodness I thought of that earlier. Cloud volume.draw. So in the test scene, all we should have to do is push back 2 new cloud volumes. Let's see. And place back clouds volume. That should work, right? There we go. Okay. And then we can, what? Cloud volume. Let's see. Cloud volume. C equals cloud. Make another. And then we'll push back clouds. Okay. And then these dot form dot position. What's up? Yeah, the YouTube random streams are pretty great. Let's see. Yeah, I'm trying to. I'll add ray marching, so it'll be like ISO balls and stuff like that I can add. ISO spheres, whatever their official term is. Let's see. Like 3 what? So this is at 0, 0, 0, I think. No, we're setting the position in the cloud. This is not the way to do things. Hold on. Scale 1000, 1000, 1000. Yeah, okay. We don't want that. We'll put this here. Total around six years, I'd say 7-ish years. Cloud 1. I started doing programming in like 7th grade, and then after that I started making video games. Thought that video games weren't like very fulfilling, honestly. I thought it was fun, but it just felt like very, I don't know, mundane. What's up, James? Hey, you should check this out. We got clouds in the game now. Although, it seems like rendering multiple of them isn't... Ah, this is what we need. We got clouds coming to the live build very soon, because I need to see how this performs on other people's computers. Yeah, we have multiple of them, and it works. Oh, we should multiply these by transform. These need to be Uno cloud. Dos clouds, actually. But, yeah, density function, ray times U transform. Oh, wait a minute. We don't want that. We want vec3 world ray equals vec4. Yeah, we got a couple. Hopefully there will be an entire, sky full of clouds at one point. But for now, this will do. Yeah, look, it's hard to get clouds. Oh, those aren't clouds at all. Those are a mess. Oh my gosh. Wow, that was terrible. Step ray, 1.9 times transform. Ah, I know what the issue is. Wait, there's an extract position method we have, right? I think I have an... Yeah, that's what we need. We just need the position from the transform. We don't need any of the scaling factor stuff. Extract position, transform. There we go. Let's see. Oh, what did I do? Extract position, vec4 to vec3. What? Yeah, you can learn literally everything. I learned everything from YouTube. Also just build projects. I never like really sat down and started watching videos or anything. It just was something I kind of, I don't know. Let's see, I'm joining here. A few friends, do the code. Oh yeah. Those are always very fun. I do hackathons if I can. Like whenever my school has hackathons, I always join in. Yeah, there we go. 2 clouds. 2 perfectly spherical clouds. But it proves that the cloud shaders are working, like the density functions. Right now, they're just spheres. Though merging them would be nice in the future. Not seeing any real alpha blending issues. We can fly through them. That's good. I can't complain. That's. Oh, I can make them look really good actually. Hold on. We have an albedo. There's an albedo that we could use. What is that? I have like 2 seconds left on this stream. Hold on. 2 seconds. Let's see. Yeah. Oh, yeah. This is good. So we'll get the density. Yeah. And then we will... What? We'll mix between white... maybe this should just return a float. Traverse volume. We'll return this. And then all we have to do is say what? Vec4 1.0 u albedo, and then extract world position. Whoa, hold on. Traverse volume, that's the issue. U albedo. And then that should fix that. I think the albedo is a vec3, so vec4 u albedo, and then 1.0. Oh, not just 1.0. Actually, hold on. Vec3 color would be mix vec3 1.0 u albedo. And then we'll mix it based on 1.0 minus whatever this is. And then we'll just say vec4 color, and then the alpha will just be that. That should work. We haven't uploaded an albedo to this yet, I don't think. But that did in fact work. And then if we were to give it a color, if we were to say, yeah, that's a really good idea. Mesh dot what is it? Bounds mesh dot material dot what is it? Dot shader. Where do we store? Yeah, material albedo. That's what it is. Okay. Dot material dot albedo equals vec3. And then we can just snag the really nice sky color I have in the environment. Skybox. It's in types. Sky color. We'll take that. Actually, we'll just take this last piece. Boom. And then that should give some cool results. Oh, wow. Look at that. Those look really cloud-like, actually. A little bright, I'd say. But, like, that works really, really well. Let's see. We'll make these a little darker. A little too dark. What, 0.9? We'll set it to like 0.8, 0.7, 0.5. We'll just reduce it by 1. And then, if this works... Oh, yeah. Clouds. We have actual clouds. We probably should have some sort of like way to blend between them, because there is some uh-oh. My frame rate just tanked. Why did that just happen? Hold on. Oh no. Okay. Is it the amount of steps? It's got to be the amount of steps. What if we really just reduce the amount of steps? Okay. And then we'll just build for the web. I'll push these changes, and then I'll have to probably optimize the heck out of this at some point, because these are not as performant as they need to be, admittedly. But they will be. They will be. In the meantime, I think that's probably going to be it for the stream. Good progress today, honestly. I didn't expect to have something resembling actual clouds done in one live stream. So yeah, thanks for tuning in. Let's see how the web build works. Please work. Please don't have everything broken. See, right when I asked, return mismatching type. Something is wrong with the... Alright, I'll fix that off stream because it's a super easy issue to fix. But yeah. Yeah. Thank you for tuning in. We'll see y'all later.